lowering now, steady on the starboard side.
Copy that, watching the clearance.
Looking good, Habu. Clear to continue taxi. We'll see you at the hold short line.
The colossal J-58 engines of the SR-71 Blackbird, now a canvas for vibrant Arctic soft corals.
Lift commence. Divers, report status.
Status green. Cable secure. Proceeding with the lift. Keep it steady. We have 3 inches on the left wingtip.
Roger that, proceeding slowly. Log the serial numbers on the inertial platforms.
Copy that. Reading 879er.
This hybrid design required specialized tooling for the afterburner.
Yes, the bleed system is remarkably complex for its time.
Camera assembly is seated. Cross-referencing the calibration data now.
Confirmed. The internal sensor array looks good. Proceed with the final security protocols. All right, easy now. 1 degree nose right. Check the jigs.
Starboard is green.
Port locked. Go for the torque sequence. All clamps secured on port 4.
Check the schematic again. We need to verify the alignment pins.
speed descending, looking good.
Roger that. Contact in 3, 2, 1. Seal is engaged.
Running the Mach sweep now.
Indications look stable across the envelope. Calibration complete.
Almost there. Easy.
Looks good. We are locked in. Great job, everyone.
The twin J58 engine configuration is now complete, creating the world's most advanced air-breathing propulsion system.
Spike alignment is within tolerance. Proceeding with engagement.
Systems check is green. Shockwave positioning active. Weight on wheels, pressure looks good.
Stance confirmed. Blackbird is stable.
Halon suppression system armed and pressurized.
Confirmed armed. Stand by for spool.
Cabin pressurization stabilizing at altitude equivalent. How's the suit connection, pilot? Green across the board, engineer. Seal is tight.
Systems check complete. The inerting sequence is validated. Pressure levels are nominal.
Good test. SAS-1 engaged. Augmentation levels nominal. Stability augmentation system validated. We have 67,510 on the main. Aft CG is steady.
Noted. Right at the limit.
Here we see the immaculately restored J58 turboramjet engines, twin mechanical sculptures designed for speeds up to Mach 3.2.
The 95 designation refers to the optical camera array, capable of...
A detailed study of the specialized landing gear highlights the titanium structure and heat-resistant brake assemblies designed for extreme conditions.
We should emphasize the SR-71's unique materials, given its speed, and the geopolitical context of its mission.
Tolerant.
The SR-71's titanium skin was revolutionary. At Mach 3, the friction heats the fuselage to hundreds of degrees.
We are documenting the fastest jet ever built. Check out how these inlet spikes manage the speed. What an incredible machine. This laser grid is capturing the complete geometry of the SR-71, ensuring its preservation for the Smithsonian and Skunk Works archives. Check the pressure differential on the intake manifold. We need to maintain positive pressure.
Confirmed. Reading stable.
This simulation lets you plot the reconnaissance route at Mach 3. See the camera deploy here?
We did it!
Excellent work, everyone. You completed the mission. Welcome to our immersive 360-degree tour of the legendary SR-71 Blackbird, the fastest air-breathing aircraft ever built. To the restoration team and the enduring legacy of the Blackbird.
Cheers! You brought her back to life. Incredible work. Thank you. We are very proud.
Today, we celebrate the grand opening and the incredible legacy of the Mach 3 Blackbird.
Get the camera ready. This is amazing.
Look, Daddy, it's flying right there.
We were cruising at 3.2, and the controller asked, "Have you reached FL 600 yet?" And you told him you were descending to it.
The SR-71 Blackbird flew so fast, its skin would heat up, requiring...
This aircraft flew faster and higher than any other. It's truly a marvel of engineering.
The bypass pipes are critical for airflow around the afterburner during the transition to the ramjet cycle.
And this weld, the speed runs were incredible, but the real legacy is what she taught us about the limits of aviation.
And the restoration?
A labor of love. The thermal expansion on these intake cones requires constant monitoring.
And the sealant along the chines is degrading faster than predicted.